Hello everyone, welcome to another Azure Cloud Native Live. We've got an awesome guest this evening, but before we get on to that, let's have a look at our terms and conditions, our code of conduct as you will. So in today's session, I would like to ask everyone to be aware of others, be friendly and patient, be welcoming and respectful, be open to all questions and viewpoints, be understanding of differences, be kind and considerate to others. And I'd like you all to ask as many questions as you can. It's going to be an awesome session. So let's bring Daniel in. Hey, Daniel, how are you?
Hey, everyone. I'm doing good, Richard. How are you?
Yeah, good, thanks. Good. So I'm really excited for this session because I love AKS, as you know, and I'm excited to see other people's thoughts, opinions, and what they get up to with it. So with that, I'll let you take it away.
Perfect. All right, there's the screen. Perfect. So yeah, welcome everyone to the session today, operating Azure Kubernetes Service, learnings from the field. My name is Daniel Neumann. I'm working as a staff software engineer for a company called Linux in Germany. So I'm part of the platform operations team, and mostly, even if it's called staff software engineer, my daily duty is like what a DevOps engineer does or site reliability engineer. I'm also a Microsoft MVP for Microsoft Azure. And yes, you find my blog and also my Twitter handle. So as time is tight, 1 hour, and we have a fully packed agenda, I just would like to start with the session objectives. So first of all, I will be talking about business continuity and disaster recovery, then going over to high availability, patch and upgrade management, and round it up with I would say it's a very interesting topic, but mostly like it's seen as a boring topic, what's called governance, monitoring, and alerting. At any time, if you have questions, just post them. I try to have a look onto the chat or comments, yeah, and then we will see how we get that into the session. Otherwise, I will answer it afterwards. And don't be scared if my phone rings during the session. I'm on call this week, so fingers crossed that no alert will happen. All right, so let's get started with the business continuity and disaster recovery topic. So from my experience, I need to say, before I joined Linux, I've worked 3 years at Microsoft as a technology solutions professional, so doing technical pre-sales, selling the Azure solutions. And for the last 3 years, operating AKS in production, I have learned a lot of things. Again, what you didn't think of when you're doing technical pre-sales, when we're looking at the BCDR topic, is like the most important point is to have a DR strategy in place. And that's very important. I will show an example and walk you through what I've experienced or we have experienced with AKS. I guess it's 1.5 years back right now. And we'll talk a bit more why you should have a DR strategy in place. And with that, it's more like the disaster recovery strategy should be fully concentrate on that you just can rotate an entire AKS cluster without any impact for your customers. So the easiest part for that is using a traffic manager as a DNS load balancer in front of AKS. I will show it in a demo how that's working. But I mean, if you don't want to use Traffic Manager as a DNS load balancer in front of AKS, you probably can use Azure Front Door as your layer 7 web application firewall, gateway, whatever. And the other important part for a BCDR strategy and doing a cluster rotation or cluster replacement is that you have so-called stateless services. Stateless might be the wrong term here, but stateless in the fact that services that need to store state, storing the state in a platform as a service like Azure Storage, Azure Database for PostgreSQL, MySQL, or Azure Cache for Redis, or whatever parse service you can think of in Azure, or any, maybe you use parse services from another cloud provider. But a BCDR strategy with a cluster rotation or cluster replacement gets tremendously complicated if you use stateful services which you run and operate in your cluster. For instance, you're hosting Postgres yourself in your Kubernetes cluster and you get disks attached to the nodes. It makes it more difficult to rotate or replace a cluster without having downtime. So jumping into the example, what we have experienced back was like, was during the normal operation hours, one of our engineers reached out to our platform team and said, okay, hey guys, I want to release a new version of our microservice and I cannot deploy to the cluster. So it's failing. So we just checked what we can, anything that we could identify was like that the kubectl commands like get ports, describe ports, all was working well, but kubectl logs, for example, didn't work. It ran into a timeout, and this was like, okay, something is really broken with the cluster. So what our strategy in that case is like, we open a server TA ticket with Microsoft. So we have a professional service support contract. And then immediately starting our DR procedure with, setting up a second cluster in the same region, deploying all our microservices, all our system services we need. For instance, we use Istio as our service mesh and is the Istio ingress gateway for handling all the traffic. So we set up a second cluster, and before we have finished that, we already were in contact with the Microsoft support, had the support engineer in a Teams meeting, and he really quickly identified, hey guys, we roll out an update to the AKS link component. It's now the connectivity component. And he said, just redeploy the ports like kubectl rollout, restart deployment. And if it does not help, we will dig deeper into it. But the restart helped to reestablish the connection between the node pools and the managed control plane. And then we could stop our disaster recovery procedure here. But in the end, if this wouldn't have helped here, we would then switch over to the second cluster, turn off the old cluster, and customers wouldn't have seen any kind of outage and impact here. So that's a small example how one way of having a disaster recovery strategy. Another one could be that you use Velero, the former Heptio-Arc product, which makes a backup of all your state of your Kubernetes cluster, and you can restore it into a newly one. So how this looks in Azure, I have a blue and a red cluster, and I'm just using a traffic manager profile, as I mentioned before. So the routing method is priority, and I have defined As you can see, 2 endpoints, red and blue, and the endpoint with the lower priority will be always the target. So it's just a plain simple microservice running on the Kubernetes nodes, which just display an HTML page in red and one in blue. And so just assuming that we had issues with the red cluster, we couldn't deploy anymore to it. We have the Azure support involved, but we didn't get any solution. And we have finished the provisioning of our replacement cluster. The easiest thing what we just can do, and probably you do it via infrastructure as code. If it's Azure Resource Manager templates, Bicep, Terraform, or Pulumi, doesn't matter. Hopefully you do it with infrastructure as code. We adjust the priority for the blue endpoint, and the DNS time to live for Traffic Manager is 60 seconds. Hopefully we will see it if we do a demo. Is it already the new endpoint? Let's check it. It's yes, it should be. And if we hit that, sometimes it's like the browser caching. I will just initiate a new private. And continue to HTTPS. Here we are. We now see the blue HTML page, and that's how we switch to the other cluster, and that's how you can do disaster recovery. Or even this is a good scenario to have Traffic Manager in front of your clusters. If you need to, just redeploy an Azure Kubernetes Service cluster for enabling, newly feature sets. For instance, if you currently use an AKS cluster with the outbound type load balance and you would like to switch to the NAT gateway type, you need to redeploy your cluster. You can't replace it on demand. That's currently not supported. But about the topic of NAT gateway and how you mitigate the SNAT port exhaustion, we will talk. We come to that later in this talk. So that's some kind of my experience with disaster recovery and so on and so forth. And now let's do the next step, high availability. This topic, high availability, does not target any kind of Azure infrastructure. So it's mostly what you as a DevOps engineer, an Azure engineer, or platforms engineer will advise your engineers or software engineers to do. When we talk about high availability and Kubernetes, we distinguish between voluntary evictions and non-voluntary evictions. So voluntary evictions, sorry for that, means that we do maintenance on our Azure Kubernetes Service cluster, which could be like updating to a new patch version or upgrade to a new minor version, doing node upgrades, etc. For that specific case, you use pod disruption budgets, and I have some visualizations to explain it more deeply. And then we have the non-voluntary evictions, which means that you experience a node outage, any kind of unexpected behavior, an application is crashing, and so on and so forth. For that, you can use the well-known pod anti-affinity settings to distribute your application across different nodes, different availability zones. And with Kubernetes 1.19 or higher, you can make use of the new, I would say new object called pod topology spread constraints, which let you easily distribute your applications across different availability zones, where you can define how much difference between deployment alignment you have. We will see it in the example in the next minutes. So I'm looking at the pod disruption budget example. We have 2 pods on our application running on node A, node B, and we have a pod disruption budget set that the min availability of our application should be 50%. So at any point in time, only one pod can be evicted or restarted on another node. And in this example, for instance, we just upgrade the Kubernetes cluster and just said, okay, we would like to not do it one node by another. So we would like to do it 2 nodes at the same time. So the first node is set into maintenance mode. All the running pods will be evicted and restarted on other nodes. So our pod moves over to node C. It's currently starting up. We have readiness probes, so the pod is not marked as ready to receive traffic yet. And at the same time, the operation puts node B into maintenance mode and tries to evict the pod that's running on node B, the only one that's currently available for our application. And at that point in time, the pod disruption budget will prevent the eviction. So it makes sure that your application is still available. And this will be only released until the other pod is available or marked as ready to receive traffic on node C. Only then the pod on node B will be evicted and restarted on another node. And that's really great. Even if you, for example, pod disruption budgets also help you if you do release a new server, a new version of your service, and yeah, you have some kind of failure or bug in your application that your pod doesn't come up. So in that case, the pod disruption budget also ensures that not all of your pods will be terminated at once to replace it with the new version. A different look at the pod topology spread constraints here for non-voluntary evictions. So outages, any kind of errors you will experience, a node failure, or maybe backend failure like the DBMS or any kind of storage goes down. And for the pod topology spread constraints, you can set a so-called setting that's called max skew. And with max skew, you defined the behavior where to place. For instance, if we would like to have a third replica, where it will land. And yeah, just running through the example here to give you an idea how this works with the max skew setting. So if we want to have a third replica, the Kubernetes scheduler will do comparison based on the topology spread constraint, how you define it. So if we set the max skew setting to 1, it will assume, okay, if I place the third replica on node A, and then it does the calculation, okay, if I place it on node A would have two replicas running of this kind of application, minus the one that's running in node B. The end result would be 1, which complies with the max skew setting. Then it does the comparison, the scheduler with node C, and then we have 2 minus 0, which results in the result 2, which doesn't comply anymore with the max skew setting of 1 because it's 2 is higher than 1. Same approach with node B, and then node C is the target node where the third replica of our service would land. And with that, we have distributed our application across all 3 availability zones, make it highly available as possible in Kubernetes. You can adjust the max skew value. I've done it in this kind of example. So if we do it again, placing the third replica with a max skew setting of 2 would be feasible that it lands on node A, on node B, and also on node C. So we have 3 different kind of scenarios where the third replica can land in. And with that, it might be that we only have our application running in 2 zones at a time and not 3 at a time. All right, that's the kind of topic for the high availability. And I really need to say that it's very important to educate your developers saying, hey, you want to have your application high available, or we as a platform operations team would like to make sure it's high available. So please use pod disruption budgets, pod anti-affinity rules, or the pod topology spread constraint to make it really high available, that your application can survive a node failure, or even when we're looking into the Azure environment with the availability zones, that your application can survive a data center failure, or even a zone failure within a region. All right. Then let's move to a bit of the high availability topic, or more it's a scaling topic when we talk about high availability. For the cluster autoscaler. If you don't have turned it on today, I really recommend to use the cluster autoscaler, because not only you get autoscaling functionality when you hit your capacity limit in your cluster, it also lets you easily replace unhealthy nodes that maybe have not been detected by the node auto repair functionality yet, but you discover it. And what's pretty cool with the cluster autoscaler is that you can manually drain the node, which will be force Kubernetes to evict all the running pods on this node, restarting them on other nodes, and mark this specific node as not available for scheduling. And what the cluster autoscaler does with its default settings in AKS is like, if a node I would say has been idling, or for a time frame of 10 minutes, has been no application pods on it, or even the cluster autoscaler decides with its calculations that it could remove this node, the cluster autoscaler will do it automatically. So if you mark a node as non-schedulable, it will be removed by the cluster autoscaler automatically. So you don't have to manually remove it, and so on and so forth. But a very important point with the cluster autoscaler is that you need to regularly check your core quota in the specific region for the specific virtual machine SKUs you're using. We were running into the issue that we forgot to check it, and then in an autoscaling event we ran into it that the cluster autoscaler couldn't provision any new nodes as we were hitting our core quota limit. So we need to raise an Azure support ticket. And luckily today it's some kind of automated. So if you even today you don't need to open a support ticket. You just can go into your subscription, select the quota, and say, okay, I would like to raise the quota to 100 more nodes, and it will be done automatically. Mostly, if it does not, you need to open a support ticket. But thinking 3 to 4 years back, it was always opening a support ticket to increase your core quota. And another important part is like, if you really run AKS in production, use the uptime SLA. If you're running it in availability zones, you will get 99.95% SLA. Without availability zones, you have 3 nines, and the free tier is only a service level objective, which means Microsoft does not guarantee the uptime for the control plane. They try to, or it's the best efforts that they try to keep the managed control plane available in 99.5% of the time. And the other point with the free tier is that the managed control plane does not scale with your API request, which you fire against the managed control plane. Where the uptime SLA, if you pay the, I guess it's 60 euros per month for each cluster, you get an automated scaling of your managed control plane, that you always get the best performance. So if you're running it in production, uptime SLA is mandatory from my point of view. The last point in high availability is application autoscaling, and I can recommend it. We use it ourselves for production. Keter has far more advanced pod scaling scenarios, or supporting far more metrics, services, which you can do your autoscaling of your application for. Than the standard horizontal pod autoscaler in Kubernetes does. It only supports CPU and memory, and I would say it's really hard to do a good autoscaling with the standard HPA. I mean, if you just get into Kubernetes, you're starting with Kubernetes. I mean, the standard HPA is a good starting point, but I would bet that that sooner than later you will take a look into Keter and start using Keter for it. The good point is it's currently in public preview. That Keter is also an add-on for AKS, so you don't need to install it yourself. You just can enable it via the add-on, and Microsoft will manage Keter for you. Like if a new release happens, you will receive sometime after the release the next version of Keter in AKS without doing anything. All right. Okay, that was like, I just thought it was a question. So patch and upgrade management. Pretty easy today with Azure Kubernetes Service. It depends on which kind of strategy you're going for. When we take a look into keeping your nodes up to date. So I'm just starting at the bottom with the automatic Kubernetes version upgrades. So you can decide if you would like to get your Kubernetes clusters automatically upgraded when a new patch version hits the AKS release channel, or if a new minor version hits the release channel, which basically protects you from using an unsupported version. So the AKS support for the Kubernetes versions is that it supports the last 4 minor versions, and within each minor versions, the last 2 patch versions are supported. Especially, you can fall out of support pretty quickly if the Kubernetes community releases are, I would say, in a short period of time, several patch versions, because they need to patch security vulnerabilities. And for example, currently, if you're running on 1.2020.6 and 1.2020.7 is released and made available in AKS, so you're also already on the latest supported patch version for this kind of 1.2020 minor version. And it should become shortly available after 1.2020.8 version, and it's made available in AKS, you're out of support. So the automatic Kubernetes version upgrade should be enabled at least for patch versions, which, as I said, protects you from running an unsupported version. So, and the other part is like, if you decide, okay, I would like to handle the patch and minor version upgrades myself, but I would like to get the Node OS image upgrades, then you can go for it. Basically, it depends on, I would guess, the engineering cycles in Azure. So mostly every week, a new Node OS image version is made available with the latest security patches and so on and so forth. But I've seen it could take 3 times 3 weeks also. I just see, will the presentation being shared? Yes, I can share the slides afterwards. Probably I will make it make the presentation as a PDF available on my GitHub repository. So it's everybody can download it afterwards. What do you use Qt and Node.js image updates together? That's the point I'm coming to, Richard. So in AKS today, you need to decide if you would like to go for the Kubernetes version upgrades or the Node.js image upgrades. You can't configure Kubernetes version upgrades with Node.js image upgrades together. So the upgrade channel defines Node.js image upgrade, Kubernetes patch version, Kubernetes minor version, and that's it. I mean, you also have this kind of, I would say, experimental upgrade channel where you just can upgrade to the latest available minor version, which is then marked as under preview for AKS before it's really battle proven and tested to make it generally available in AKS. So if you decide for doing the Node.js image upgrade path, I wouldn't recommend to run the Kubernetes reboot daemon, cured, to apply the security patches that requires a reboot of your node. If you're going for minor or patch version upgrades of Kubernetes, I highly recommend to use cured, as you then keep your Kubernetes nodes up to date. And it totally depends on how you configure cured. For instance, what we are using is like we configured the automatic Kubernetes version upgrade for patch versions, as we would like to have further testing and evaluation of minor version releases. As you might know, Kubernetes has a new lifecycle time that Kubernetes objects are a pretty good example was the horizontal pod autoscaler or cron jobs. They have been marked as beta v1. So every API version or every object in Kubernetes has an API version, and in the past, those kind of objects have been as a beta API version forever. And then the Kubernetes community decided beta versions need to be made a stable API version, I guess 3 releases after. So every quarter, or did they strip it to every 4 months, the Kubernetes release? It needs to be stable. So what can happen with minor versions upgrades that the Kubernetes community decides that this kind of specific API version is deprecated and not available in Kubernetes anymore. And that's why we decided to use the patch version combined with cured. So as Microsoft, the standard deployment for the operating system of the nodes is Ubuntu. And in Ubuntu, it's basically a default setting that Ubuntu will install security patches on a nightly basis. Some of the security patches don't require a reboot, but some require a reboot, and that's where it comes cured into play, which then checks for a specific file if it's there. And depending on how you have configured cured, so we configured cured to do the node reboots on Saturday and Sunday. So if something, so we don't have some interference during our, I would say, business hours. And then it puts a lock in Kubernetes for the specific nodes that's going to be rebooted. Only one node at a time will be rebooted, and if it doesn't come up, cured will not continue the reboot cycle, so it will be stuck. It can be configured that it will be continued. But to answer, using Richard's questions, it totally depends on your use case. If you're highly interested to keep your nodes as up to date as you can, you will combine Node OS image upgrade with secured reboot event. So the next question. That's a tough one. Using the application gateway ingress controller or the app gateway with Nginx. My answer to that would be like, we use the Istio ingress gateway as Envoy is a high performance ingress controller, but I'm not, I need to say, I'm not really a friend of the application gateway. Version 1 was horrible to get out rule changes. It could take 20 minutes. I know that version 2 is more, is a lot faster at that point, but I have seen some really weird behavior. Yeah, and it totally depends on if you would like to having automatically configured your ingress rules by the application gateway ingress controller, or if you really say, okay, we place the application gateway in front of our Nginx, just enable the web application firewall for it, and then just routing all the traffic to Nginx and decide that Nginx does the ingress routing. Depends on what you would like to do. But if you use the application gateway ingress controller, the application gateway acts as an ingress controller. And I mean, if you're familiar with Nginx, it might be the better option to go with the application gateway with Nginx. Totally depend on your knowledge, on your use case. Yes, we use the AKS maintenance Windows feature to also doing the Kubernetes patch version upgrades only on weekends, on Saturday to Sunday. Next question, how can we revert the Kubernetes version? As far as I know, that's not possible with AKS. So if you upgrade it to, I would say 123.x, and you would like to go back to 120.20, it's a cluster redeployment. Richard, you can correct me if you know it better, but
yeah, I put a little link in. It's on the it's on the roadmap for them to do a rollback.
It's on the roadmap. Good to know.
It's still in the non-development phase, so it's coming. Don't know when, but one day.
All right. Okay, let's continue to the last part, and hope I guess we have enough time. We will make it. Governance, my most favorite topic. Governance with Azure Policy. So Azure Policy for Kubernetes is using the open source implementation of the open policy agent for Kubernetes. It's called Gatekeeper. We at Linux, we have operated Gatekeeper natively before we switched to Azure Policy for Kubernetes. The main reason why we switched to Azure Policy for Kubernetes was like that they delivered the custom policies, as we have certain kind of policies which weren't available as policies are in Azure Policy. But it makes it so easier to operate Gatekeeper, as you know, all the add-ons, if it's Keter, Dapper, or the Azure Policy for Kubernetes thing, is like Microsoft takes care of version updates, applying best practices, what the configuration with Gatekeeper does. So why you would use some kind of like Gatekeeper, and there are other solutions available in the market. Kyverno is a very famous one beside Gatekeeper. So why you would use it? Enforced governance settings. It might be that you would like to set certain kind of labels for that your developers need to follow. That's some kind more like a governance topic that maybe every deployment needs a label with the cost center. The second point, enforce security settings. And I would say that's the one of the most important parts when looking at Kubernetes. So Kubernetes is not secure by default. I would say it's more open by default. It needs to be make it secure. So like no privileged containers. That containers needs to be running as non-root, read-only file system, and so on and so forth. So if you just deploy, I would say, a Docker, a container onto Kubernetes, and you don't specify any security settings, it will start up as root context. And as you might know, root is pretty bad, as you can do everything. If you don't have a read-only file system, you can an attacker can persist within the container as long as it runs. So security settings to be enforced. The other setting is like compliance settings, that you only allow certain kind of images. I would say more like certain kind of image registries. And the other one is possibly mitigating CVEs until a fix is available. The CVE number I've listed here is the is the famous man-in-the-middle attack, which is I wouldn't say it's a design error in Kubernetes, but it's so deeply integrated in Kubernetes that there is no real fix available today. So what you can do is spinning up a pod, define a service object definition where you're saying, okay, I don't want to be this kind of service object from the type load balancer or node port. It should be just cluster IP. And then you can define an external IP, for instance, 8.8.8.8, which is the DNS server from Google. And when you apply this kind of service object definition to your pod, basically every request to this specific IP address won't go to the Google DNS server. It will go to my pod, which I have deployed to Kubernetes. And this is on, I would say, multi-tenant Kubernetes cluster environments. That's a pretty big issue, as you just, it's easy. It's the easiest way to set up a man-in-the-middle attack directly in the Kubernetes cluster, just using plain Kubernetes capabilities. And this can be mitigated by having a policy engine saying, okay, I disallow defining external IP addresses in my service objects. So the next point, monitoring and alerting. I will just talk about the diagnostic checks within the demo. You should probably have a monitoring solution available. That can be Azure Monitor for Containers or Container Insights. You can have any kind of other monitoring solution, if it's Datadog or what have a New Relic, for instance. Totally depends on you, on your environment, what you have. Talking about Azure Monitor for Containers, you can enable recommended alerts, like configuring alerts when pods hitting the out of memory issue. So if a pod tries to consume more memory as its limits, Kubernetes will trigger, or basically the application will run in an out of memory error, and Kubernetes will restart the pods. That's some kind of the recommended alerts you have. But be cautious with that. Some recommended alerts can be pretty expensive. But you will see a rough estimate based on your cluster size when you configure it. And what you can use Azure Monitor for Containers, pretty straightforward for log query alerts. We basically use them to get alerted on specific patterns we see in our logs. Besides the fact that we have an application performance monitoring in place, where we also receive alerts for. And that's only covering the application part of your microservices that runs in Kubernetes. The other part is enable the AKS control plane logs. Most of the time, you won't need them, but if you need them, you need to activate them. You'll mostly have missed the point where you might needed the information. And that is really a recommendation that you should follow. Store the control plane logs in a storage account. If you ingest it into Azure Log Analytics, you will burn money for sure. Even small Kubernetes clusters emit, especially the kube audit log, which is most interesting of small clusters emit per day, I would say roughly 14 gigabyte managed control plane logs. Large clusters, more. So what we have done is like we just store the control plane logs for 3 days in a storage account. And last week we had the case that one of our engineering teams reached out to us, say, we have pending pods in the East-US location, and the cluster autoscaler does not work. So in that case, the only way to identify the issue is looking into the control plane logs. And it was very interesting as we couldn't get any kind of, for example, from our VNets in the Azure portal, we always hit a 500 error that the network resource provider wasn't working. And looking into the cluster autoscaler logs for our East-US region, it really identifies that the cluster autoscaler couldn't talk to the network resource provider and then said, okay, I wouldn't do any scaling action for the next hour. And we already had opened a support ticket, and it was some kind of bugs that the Microsoft engineering team quickly fixed in East-US at that point in time. The other thing is like, if you would like to have not navigating through your Kubernetes clusters for a kubectl or a terminal, Kubernetes resources in the Azure portal are very nice. So let's jump into another demo. And what I said is the AKS diagnostic checks. You will find them if you hit your AKS cluster on diagnose and solve problems. And it takes a bit that they are loading. Seems to be that they have getting a bit slower. So what you can do here is like saying, okay, I would like to have a check about known issues, availability and performance issues, or connectivity issues. And I guess we will just hit the first one. So I guess it's a good practice to regularly run those diagnostic checks, as they easily identify if your cluster has some kind of issues, incompatibilities, which you might want to tackle. So this kind of checks if my cluster have configured the uptime SLA, if I'm running Helm 2, hopefully not anymore, as Helm 3 doesn't depend anymore on the server component called Tiller as Helm 2 does, which most likely had cluster admin access in the cluster, which is pretty bad as you take over the Tiller component of Helm 2, or you can do anything in the cluster. Node CPUs, if I have any out-of-memory killed ports, and restricted VM sizes, and so on and so forth. I can hit the view details if I would see like any kind of issues, and I would get a recommendation how to solve it. So if you have a problem in your AKS cluster, that's your first address where you should do some diagnose and solve problems checks, depending which kind of issues you have you would run the appropriate check here. The node health is like, okay, it's again going about other checks we already had. So that's it's very helpful to easily identify where the issue is, and helps you opening the support tickets that you get. I would say the best amount of support, but that's to be discussable. I would say some might know that that you could have a bad day with the Azure support, and yeah, and on the other hand of side, you can have good days. Yeah, totally depends on the support engineer. What I mentioned was like the Kubernetes resources. You see directly underneath is I just can take a look into your cluster without using kubectl. You see the deployments, the different pods that are on your cluster, and maybe can dig deeper into it a bit. Like, so I can see which kind of labels, which kind of containers are running, which version, conditions. You can see the YAML template, copy, paste it, adjust it. Events, if we would see events for that. And you can also turn on, and that's only possible if you have used Azure Monitor from containers. You can turn on the live logs, and you would see directly log lines appearing here if the container emits logs to standard out and standard error. Yeah, and the other part is like the monitoring part, insights, and if you asked yourself the question, where do you find the recommended alerts? They are above here. They are still in preview, and they added a lot that you get alerted if the CPU usage hits a configured threshold on average, the memory working set, failed pod counts, and so on and so forth, which you can do. Yes, indeed, they have been in preview for a long time now. Hopefully they wouldn't be reworked and removed from this thing. All right, so as we hitting the end, let's talk about one of my favorite topics when it comes down to monitoring alerting, as the so-called SNAT port exhaustion. Maybe you already experienced it in Azure Kubernetes or any kind of other PaaS service. It's also possible. But I would say you would mostly like running into the issue with Azure Kubernetes Service. So just briefly explain what is an SNAT port exhaustion. So for every outbound request a pod makes in Kubernetes to an external address, it needs to use an SNAT port. And for instance, if several pods tries to reach the same public address on the same port, how can Azure distinguish which kind of those connections belong to which port? For that, it uses an SNAT port, which will be assigned to the connection or to a node already. So SNAT ports are pre-allocated to nodes and used for that kind of specific separation or identification between different connections from different ports to the same target. And it's very important to know what counts in to this kind of SNAT connections. So every access to Azure PaaS services without private link. So if you're not using private link for storage databases or cache for Redis, those kind of connections to this Azure PaaS services will count into the SNAT connection. access to external services, which means that can be services that are hosted on another cloud provider, or any kind of other external services running with a public IP. And now the important caveat comes. If you don't use private AKS cluster, every call that it's made from within the cluster to the API server is also an SNAT connection. So plain speaking, you have written your own microservice that needs to talk to the Kubernetes API to gather certain kind of things and do something with that. Even depending on which kind of service network you have defined, the cluster IP for the Kubernetes service object, which represents the API server in the cluster itself, will be different. But here you see it's an overlay network, so you have a private IP. But if you take a look into the endpoints, it's the public IP address of the API server. So, and that shouldn't be underestimated when you plan your available SNAT ports you assign to an AKS cluster. If you make a lot of API connections within the cluster itself, keep it in mind, if you don't use an AKS private cluster, that those connections also count to your available SNAT connections. And for instance, Keter, Gatekeeper, all those services talk to the API server, for instance. So how you can mitigate that kind of thing or reduce the risk to run an SNAT port extortion. So the first option is assign enough public IPs to your load balancer. So as AKS in the standard configuration uses standard load balancer, the standard load balancer needs a dedicated public IP for its outbound rule to establish outbound connection flow. And each public IP assigned for the outbound connection flow supports 64,000 SNAT ports. Sounds a lot, but believe me, if you make a lot of outbound connections, it's not. So that's the first thing. Then you should assign a custom value for the allocated SNAT ports per node. So if you depend on the default assignment, it depends on the cluster size. So if your cluster has 0 to 50 nodes, each node would get 1024 SNAT ports assigned. If you have large clusters with, I guess, 1000 nodes, every node would only get 32 SNAT ports assigned, which is pretty low by far. So plan it. We have, in our case, we have made good progress or a good experience to allocate roughly about 4,000 SNAT ports per node and setting the TCP idle reset for the load balancer to 4 minutes. Per default, it's set to 30 minutes. So if a service opens up a connection outbound, it uses an SNAT port. And if the connection idles for 30 minutes, then the SNAT port will be released and made available in the pool again. And that 30 minutes is a long, long time here. Yeah, but the point here is like you will still have the risk running into an SNAT port extortion depending on how many outbound connections you will initiate from your cluster. The second point, and that is by far the more convenient solution, use the Azure Virtual Network NAT. Because the Virtual Network NAT can have, as of today, 16 public IPs assigned. And if we do a quick calculation, 16 multiplied with 64,000, we have over 1 million available SNAT ports. And those SNAT ports will be dynamically assigned and used by the virtual network NAT. So in the first scenario, and I don't need, I guess I'm running 5 to 10 minutes over time. I hope that's fine, but I would like to wrap this important topic up here. If you use the first scenario and you pre-allocate the SNAT ports per node, so it might be that a node needs more SNAT ports than you pre-allocated to the node, and other nodes would be happy with, I would say, 100 SNAT ports assigned and don't need the other 900,000. So that's a bit of the caveat with the first scenario. With second scenario, the virtual network NAT handles, I mean, if a node needs to initiate 10,000 outbound connections and need 10,000 SNAT ports for it, it will get it. And so it's very dynamically and scalable at that point. And now comes, which I would say can be open for discussions. That's my opinion. Do not use the newly introduced outbound type of managed NAT gateway or user-assigned NAT gateway in the AKS configuration. And I will tell you why you shouldn't do that. So why you should stick to the outbound type of load balancer, which we have known it for, I would say, since AKS switched to the standard load balancer type. So a virtual network NAT always takes precedence on all outbound scenarios. That's clearly stated in the documentation, as I quoted it here. So even if your AKS cluster has the outbound type load balancer and has an outbound rule, all outbound traffic will go through the virtual network NAT once you enable it on the subnet that the AKS cluster uses, and not through the load balancer via its outbound rules. And I have some screenshots to show to you that it's really working that way. So the other important part here is when you use the managed NAT gateway or user-assigned NAT gateway option, you cannot recover yourself from a virtual network NAT outage without redeploying the AKS cluster. That's the point and spirit today. So if your virtual network NAT or the virtual network NAT service in the region you're running your microservices that, depending on outbound connections for certain kind of things that they need to manage or need to reach, and the virtual network NAT in that kind of configuration would have an outage which lasts for 2 or 4 hours, basically your application cannot perform as intended. So it wouldn't have any outbound connection. I mean, if a customer tries to reach your microservice, it will go through the public IP that's assigned to the Azure Load Balancer for inbound traffic. And this kind of IP will be used to send a response. That's standard network behavior. But if, for instance, your microservice needs to talk to a Azure database for PostgreSQL, and you haven't enabled private link, it uses a public IP, and now you have outbound traffic where you need the virtual network NAT. And if it's an outage, you can't reach it. And you can't recover your AKS cluster, as you cannot switch easily to the outbound time load balancer. And that's the reason why you should still use the Azure Load Balancer as an outbound type and just enable the Azure Virtual Network NAT on the subnet for your AKS cluster, because if the virtual network NAT has an outage, you just disassociate the NAT gateway from your subnet, and your services will automatically be using the outbound rule via the load balancer. Don't believe me? See the proof. So I've created these screenshots yesterday evening. So on the left-hand side, we see the load balancer outbound, the sum of used SNAT ports for Kubernetes. If we just strip it down to the minute, between 60 and 70 SNAT ports are used. It's just a small cluster. So once I enabled the NAT gateway on the subnet, you see that the used SNAT ports for Kubernetes drops till 0. So here it took a lot of time as I didn't set the TCP reset on the load balancer from 30 minutes to 4 minutes. But in the end, as you can see, it really drops to 0 and all the outbound traffic is handled by the NAT gateway. And now the scenario, like the NAT gateway has an outage, you need outbound connectivity, you just dissociate it from the subnet. The NAT gateway connection count went to 0, and on the Azure load balancer, again, it went up. Summary before I take a look into the chat and answering all the questions you may have asked in between. So I guess the most important point is, if you haven't it today, have a disaster recovery plan in place. The worst thing that can happen is that you have an issue with your AKS cluster. You need to replace it, redeploy it, switching over to the new cluster to keep your services available, and you don't have a DR plan, and then you need to think about how do I need to execute it. That's the worst thing that could happen. I mean, it happens a lot. You will have your learnings from it. But I totally can recommend. It's good to have a DR plan in place, and if such an event happens, you can pull it up and just walk through it. It's really saving and relaxing. And the other case is, if it is possible, use as much platform as a service services as you can, and it makes it a lot easier to replace or rotate a cluster. Second point is educate your developers and engineers to really use the Kubernetes principles like pod disruption budgets to prevent outages of the microservices due to voluntary evictions like maintenance, patching, etc., and using pod anti-affinity or pod topology spread constraints for non-voluntary evictions, for outages, node issues, data center failures, regional availability zone failures, etc. The other point is keep AKS up to date, which means keep Kubernetes versions up to date. If there's a new Kubernetes version released which fixes a security vulnerability, keeping the nodes up to date, because if you implement proper governance, that you're following security best practices in Kubernetes, but your infrastructure is vulnerable to certain kind of vulnerabilities, that's only halfway to a secure cluster. Have monitoring in place. The worst thing that can happen is your service has an outage and you don't recognize it out of the logs because you don't receive alerts, you don't have configured alerts, or seeing high CPU usage. That's the other case. It's pretty worse. So all in all, I mean, it's not nothing fancy new stuff that we need to keep in mind for Azure Kubernetes Service. It's I would say the plain basics for decades working in IT, monitoring, alerting, governance, keeping your services, your operating system up to date. That's all for today. Thanks for listening, and I would like to see if we have, and maybe Richard, I see that you have been responsive on the chat, that you can help me if we have any open questions left.
So one of the questions was about what do you sort of do for checking your probes and alerting when your liveness and readiness probes go. So I said about contain insights, and you could look for pod restarts and that. What do you kind of do for that?
Probe issues.
Yeah.
If you have configured readiness probes and liveness probes, you wouldn't see them in the logs. So, I mean, it's a Kubernetes primitive. that's a kubelet. That's another service by Kubernetes that sits on the node and does the thing of sending the probes to the servers and depending on the configuration, if the service is ready, if it's dead or not. But where you can see, I would say so. Where you can see such kind of events is like if we take a look into the Kubernetes resources again, and you probably know the pod. I'm just picking a random one. You could see in the events. So mostly Kubernetes events. I mean, let me show it to you. Hopefully they. So mostly you do. So I have aliases for it. That's a kubectl describe pod. You would see events here then, but you only see events that happened in the last hour. So in the last hour here, nothing happened in this specific pod. If you want to see if you didn't recognize it directly, and you would see the Kubernetes events for some of your containers or pods, you can go under Insights, Containers, and let's check that one here. Oh, that was one too many. So you can see live events that are emitted by the container itself. But you should also have, where it is, live events, view and log analytics. And I guess it's only kube events, set the query time. Okay, we just want to, let's see if we find something in the kube events. Nothing for the last 24 hours, last 7 days. Okay. My goodness, it's running in the kube system. So kube system thingies are not interested by the logs. So sorry if that's my fault, but let's pick another one. Yeah, just going for one of my pods. And hopefully if I remove that and set it to probably 7 days. Oh, I guess they are running too long for it now.
You
but
could
mostly
try removing line 2 as well. The contain. No, not line 2. The line 4, where the name equals the go app, and then it might pick up more.
Yeah, I mean, just if we remove that, we. Oh no, I know where the issue is. It's like the object kind. It should be pod. So if we use pod and I just remove that and then turn it to 24 hours, we should see something. Oh my goodness. Here we are. Right, it's already collecting it, but we had the wrong object kind. And there you can see, for instance, the connectivity agent readiness probe failed. Context stack line exceeded. So you get it also in the logs.
Hopefully so you could just do like you could KQL query, set the alert by clicking on the little alert button somewhere on here. Then just get some emails or Teams notification every time it goes on, which will be cool.
Yeah, I mean, you can even hit the new alert rule and create it out of the box if you don't want to use it via infrastructure as code. So that was that. Then
and
I guess that was.
Someone wants to know your Git repo, so if you want to bring that up on screen.
Oh, yes. So it's pretty easy. It's, leaves this page. And then I will head a repository, I guess it's speaker slides, So
cool. Nice and easy.
Yeah.
Awesome.
So probably upload the slides tomorrow. again, thanks for listening. Hope you found it insightful, taking some notes, taking some things that you haven't known before, making your AKS experience even better, or not only your experience, also the experience of your colleagues, your customers, whatever. I mean, if you're working with AKS, I guess, or even running your own IT system, serving customers, it's a top priority that you keep your customers happy. And most likely, how keep your customers happy is that you have a fast, responsible, and high available system.
Yeah, definitely agree with you on that one. Awesome. So thank you very much, Daniel. And with that, I will end the stream. So thanks everyone for watching, and we'll see you next time.